Hello everyone, welcome back to Cambridge Guru. Last video was about profit and loss. In this video, we will learn what is called as the interest, right? So, what is interest? Interest is something that bank gives you when you deposit certain amount of money with the bank. For example, if I have $1,000 with me and I am depositing these $1,000, there can be number of reasons why I am depositing my money with the bank, and we are not going into the reasons why an individual deposits some money, right? So we just deal with the mathematics behind the interest. So a bank gives you certain amount of interest on a percentage basis. For example, I have $1,000 with me and I'm depositing these $1,000, and bank is giving me the 10% interest, meaning after 1 year, this rate of interest is for 1 year. So after 1 year, I will get the 10% extra money if I want to move out my original money also, right? So let us take this simple example only, that I have $1,000 with me and I deposit this $1,000 for 1 year, right? And bank is giving me rate of interest as 10%, right? In the language of mathematics, in simple interest, we call the original amount that we deposited, in this case $1,000, I call this as the principal amount. I call this as the principal or simple principal, right? Not the amount, denoted by capital P. This rate of interest, which is 10%, I call or denote this by capital R, right? Now, as I said, bank will give you 10% in this example, which is calculated on the original amount that I deposited. So I just find out 10% of, this is my 10%, and the principal here is $1,000, right? So this money, this value comes out to be $100. I call this $100 as my simple interest, and I call this as simple interest for, let us say, after 1 year, right? Now, if I have to find out the amount after 1 year, so my amount is basically, if I have to move out my original money also, so meaning is amount is your addition of the original principal, which is P, plus the simple interest after 1 year. So let us say this is SI1, right? So amount after 1 year comes out to be by adding principal with the simple interest, right? So this formula you need to remember for the amount, and I'm just giving you the formula for simple interest also, right? Now let us move to the second year. If I have to, let us say I'm not moving out my money and I'm depositing that money for, let us say, for 2 years, right? So now interest for the second year will also be calculated on the original amount, which was $1,000. Okay, so again I will find out the 10% of that original amount. So this is original amount and this is 10%. Okay, again this simple interest for second year will come out to be $100, right? And I need to find out the interest, let us say, after 2 years. So I will add the interest of first year plus interest of second year. In this case, this comes out to be $200, right? Now, as you can see here very clearly, that instead of adding the interest one by one or year, it is rather simpler mathematics to multiply the interest of 1 year by the number of years, because the original amount or the interest is calculated on the original amount, which is not changing. Okay, so for the first year, what I have actually calculated is the rate, which is R. So let us say rate was 10%, so I write R by 100. If rate is, let us say, if rate is 10%, so I'll write 10 by 100. If rate is 8%, so I'll write 8 by 100. So basically what I have calculated here, 10 by 100 is, it is basically R by 100. If rate would have been 8, so I would write 8 by 100, right? And this 1000 will remain same. So I denote this 1000 by this letter P. This is your R. So this is your interest for 1 year, right? And if I have deposited this amount for, let us say, T number of years, so what I will do is I will just multiply this interest with the number of years denoted by T. right? So this is the interest that you will get after t number of years. For 5 years, you will just multiply rate of interest, which is PR by 100, by the number of years for, let us say, 5, right? So 5 into PR by 100. In this example, if P is $1,000, rate is 10%, so my interest would have been $500 for 5 years, right? And the amount, of course, we should not forget this formula, that amount will be equal to the original principal, which is 1000, plus the interest after 5 years, right? So after 5 years, total amount would be 1000 plus 500 is $1,500, right? So here is the formula for you, which is of the simple interest. So right here as simple interest is actually multiplication of P, R, and T divided by 100. Okay, this is the formula for amount, and this is the formula for simple interest. Okay, let us do a couple of questions based on simple interest. Sometimes, as you can see here, there are 4 variables involved. One variable is your P, second variable is the rate, third variable is the time, and lastly, fourth variable is, of course, simple interest. So out of these 4, 3 values will be given to you, 1 will be asked. Okay, and of course there is another equation which adds principal and or relates principal with the simple interest also, which is the amount. Okay, so we have basically 5 variables. Out of these 5, 4 will be given to you, 1 will be asked. Okay, so let us start question number 1, which says find a simple interest earned on $250 deposited for 6 years at 8% per annum. We call this is a shorthand of writing per annum, annum meaning annually. So the bank is giving you 8% of interest annually. Okay, so this is for per annum. Yes, ANNUM, if I'm not wrong. Okay, so simple interest here will be PRT over 100. Here principal is 250, rate is 8, and time is 6 years over 100. Right, simple interest questions can come in your non-calculator question paper, although this is not fixed, but most of the chances are of simple interest only. There is another type of interest which is our next topic, which we will do in a couple of minutes. So chances are that questions which involve second type of interest that come in the calculator one, because it deals with some exponents. Okay, so 250 into 8 into 6 by 100, so 0 goes with this goes 5 times, 2 times, this is 4, so 5 into 4 is 20, 20 into 6 is 120. So simple interest in this case comes out to be $120. Fine, this is your part A, simple application of PRT by 100. Second says, how long will it take for a sum of $250 invested at 8% to earn interest of $80? Right, this time it says that interest, if I have to receive as $80, rate is same and original amount is also same, which is 250. So for how long I need to deposit this much amount to get $80? Okay, this time it is basically asking the variable t. Okay, so here simple interest, same equation I need to use here, so I will just put in the value in the same formula, no need to write formulas again and again. So this is interest 80, principal is 250, rate is 8, and t is your unknown over 100. Right, this 0 gets cancelled with this, and again this goes 2 times, this goes 5 times, this goes 4 times. So t is for 4 years. Yes, 80 by 20. This is t. So t comes out to be 4 years. And what does it mean? It's very simple. For 4 years, if you have deposited $250 and you are getting 8% interest, so you will get $80 as your total interest after 4 years. Okay, $20 for each year. Fine, let us move to the next question, which says what rate per year must be paid for a principal of $750 to earn interest of 180 in 4 years. This time I need to find out the value of R. So let us find out value of R. Interest is given as 180. So 180 is equal to 750. Rate is, I need to find out, yes, T is 4 over 100, right? This goes with this, 25 3 times, not 25, I should cancel rather this 0 with this one, right? So now 25 goes 3 times, this 25 goes 4 times, 4 gets cancelled with this. So rate in this comes out to be 18 by 3, which is 6%. If I'm writing here 6%, that doesn't mean rate, the value of R is 6 by 100. Okay, that 100 is incorporated in the original formula. So basically R should be, the value of R should be 6, not the percent, right? But as we say that rate at what percentage, we talked rate as in terms of percentage, that's why I have written this as 6%, right? So to be more precise, I should remove this percentage sign. So it is just 6, and in words you will say that rate of interest is 6%. All right, next one is find the principal which will earn interest of 120 in 6 years at $40. This time it is asking for principal. So again 120 is equal to P, rate is 4, time is 6 over 100. This goes 25 times. This goes 20 times. So principal comes out to be $500. Okay, fine. Now let us come to the next topic, which is compound interest, right? So as you can see, interest is of two types. One that we have already learned, simple, and second is the compound. So the only difference between simple and compound interest is this. Let us take the same example that I have $1,000 with me. I carry these $1,000 and deposit this in the bank, and bank is giving me rate of interest as 10%, right? And if I ask you what is the amount after amount, please remember it is not the interest, right? Amount I'm asking, so amount after 1 year comes out to be interest plus principal. So principal was 1,000 and interest after 1 year will be 100. So total amount comes out to be 1100. Now for the second year, in case of compound interest, the interest will be calculated on this amount 1100, not on the original amount 1000. Right? I'm again repeating, in the case of compound interest, interest is calculated on the amount that you get after successive years, not on the original principal amount that you deposit in the very first year. Right? And this is the difference between simple and compound. And as you can see here, that since now the interest for the second year, let us say interest on second year denoted by 2, I2, this will be calculated. So 10% will be calculated on this time 1100, which comes out to be $110. So if you compare the interest after second year, in case of simple interest, that interest was 100, but in this case, in the second year, we are getting $10 extra. It is because we are dealing with compound interest, and to be more precise, the interest now is calculated on the recurring amount. Okay, so this is the difference between compound and simple, right? And we have a formula for finding out compound interest or compound amount after n number of years, right? Although there's a very basic definition also or derivation also behind the basic formula of compound interest, right, which you can also find out, but for that we should know, or we should have some idea about the geometric progression. Okay, so for now I'm just giving you the formula for finding out the compound amount. Okay, so compound amount, I should use CA, which is P into 1 plus R by 100 raised to power T. Sometimes they use the variable N also for number of years. Okay, this is the formula for finding out the amount after t number of years if rate of interest is r and original amount is p. Okay, and remember the difference between this one and the previous simple interest is this. I'm not talking about the conceptual difference. I'm talking about the differences in the formula. In compound interest formula as such, this formula gives you, remember, the amount. Okay. If you have understood the concept between amount and interest and principal, so there is no need to remember the formula for simple interest amount. Okay. The formula was of PRT by 100, which was of interest. Once you have found out the interest, you just add this to the original principal. So no need to remember the second formula for amount, right? But here we need to remember this formula for compound interest, and this is actually not the interest. It gives you the amount after t number of years. Okay, and if I have to find out the interest which is calculated compoundedly, okay, so for that I should write compound interest is rather p 1 plus r by 100 over t, raised power t, and from this amount if I subtract the original principal, so this time I need to subtract p from the amount to get the interest. Okay, this is just for the sake of understanding. No need to remember this formula. What you need to remember is this one, compounded amount. Okay, and it doesn't matter what you write on left hand side as far as calculator based question is concerned or 2 or 3 question marks are concerned, right? What Cambridge is interested in finding out the correct method and the right answer, right? So you just start by, or you can also write down the amount is equal to p1 plus r by 100 raised to power t. So important one is the right hand side, which is written in compound amount formula, not the interest formula. Okay, now as I said I need a calculator for finding out the, or for solving some questions on compounded amount. So get your calculators ready. Question is in front of you, so you pause the video once the question comes and start solving. Okay, so let us do question number 1, which says find the compound interest paid on a loan of $600 for 3 years at an annual percentage rate of 5%. It is just the value of r. Okay, so solution is this. What we have given is loan of 600. So this time this is a reverse process. I am not depositing any money, but rather I have taken a loan from the bank, right? And I need to give the interest as the compound interest. It will be calculated on the amount after successive years, not on the original loan. Okay, so formula will remain same. So amount, compounded amount CA will be equal to 600 1 plus r, so rate of interest is 5 by 100 raised to power 3. This is the amount, right? So we just, let us say, calculate this. So 600 into this comes out to be 1 point, and this is a very good idea to deal with compound interest if you know the idea of multipliers. Okay, so if the value is very easy or easily divisible, so you just write as 5 by 100 as 0.05 and add this to 1, so this comes out to be 1.05. okay, you can directly write this 1.05. I call this as a multiplier. Okay, this we will deal in further percentage topics also, right? So this multiplier is for 3 years, right? And why I'm calling this as a multiplier, because on the original amount, whatever is the amount, whether it is the principal or the amount after successive years, rate of interest comes out to be 5%. So 0.05 you need to add after each year, right? So 1.05 you will get after each year, right? And this will be multiplied to the amount, right, after 3 years. So for successive years 1.05 has to be multiplied. That's why 1.05 is raised to the power 3. Okay, so you just get your calculator. Let me find out this. 600 multiplied by 1.05 raised to power 3. This is $694.575. This is the amount that you will get after 3 years. Okay, but it was asking about the interest, so compound interest is basically 694.575. This, you subtract 600 from this amount, so you get actually $94.7575 as your compound interest. Okay, I hope it's fine. Okay, let us do the next question. It says a man owes $5,000 on his credit cards. The rate of interest is $20. The rate of interest is 20% per year. If he doesn't repay any of the debt, how much will he owe after 4 years? Right? Again, it's a question of compound interest. So if he doesn't repay any of the debt, so we need to just find out the amount after 4 years. Right? So it is just P1 plus R by 100, so 20 by 100 raised to power 4. Here the multiplier will be 1.2. So 5,000 multiplied by 1.2 raised to power 4. So 5,000 into 1.2 raised to power 4. This comes out to be $10,368. So just see the effect of compounding. And why this is coming out to be a big value. First, the rate is very large, which is 20%. But again, if you find out the simple interest for the same amount, for the same rate, you won't get as 10,000. Money is almost doubled. It's the beauty of compounding, right? Next question, how many years will it take for a debt to double at 15% per annum compound interest? So this time I need to find out the exponent t, number of years I need to find out, right? And it says for a debt to double. For a debt to double meaning that whatever is the amount, that has to be doubled. So after how many years the original amount will get doubled if the rate of interest is 15. So let us say original principal is P, right? So P1 plus rate of interest is 15%. So I just write 0.15 and this T I need to find out. Now this is the amount after T number of years, right? And this is the double of the principal amount, right? So I should equate this to 2P. So far so nice. This is twice to get double. Okay, so the final amount is the double of the original amount. So original amount is P, so I write this as 2P. So what I do is I just cancel this P with this P. So 1 plus 0.15 raised to power T is equal to 2, meaning 1.15 raised to power T is equal to 2. Now there are two ways to solve this exponential equation. First, what is an exponential equation? As you can see here, the variable is in the exponent. Variable is in the exponent. That's why I'm calling this as an exponential equation, right? And how to solve this? There are two ways. One is what we call as taking the logarithms on both the sides. What is a logarithm? Logarithm is used to solve some exponential equations, right? But this logarithm is not in your syllabus, right? This comes in A level, right? In pure math, A level, there is a topic logarithm. There we are going to study this. Now, how we solve this? Second method comes out to be trial and error. Trial and error, right? So just put a value in place of T in your calculator with base as 1.15 and see which value is coming out to be closer to 2. So if I take, let us say 1.15 raised to power 3, this comes out to be 1.52. So T is in fact greater than 3. Let us put this as 6. this comes out to be, if I'm writing 1.15 raised to power 6, this is coming out to be 2.313. It is greater than 2. That means the value of t is lying between 3 and 6. So let us put 5. In place of 5, I'm getting 1.15 raised to power 5 is getting 2.011. Right? And if I write 1.15 raised to power 4, this comes out to be 1.749. Now if you take the 3 significant figure, rounding it to 3 significant figures, this is way closer, way lower than the value 2. Okay, and if I round this to, let us say 1 SF, so I will get as 2 value, right? So I will take this is the correct equation, and having said that, my value of t comes out to be 2, sorry, not 2, t comes out to be, this corresponds to 5, so t is 5 years, approximately, of course, right? Let us take some more questions. Yes, there is another, you can say, a slightly note to this topic is sometimes the rate of interest is not calculated annually, rather it is calculated half yearly, right? Meaning if you have deposited $1,000 in a bank on a, which is giving you compound interest, so but there is a scheme which is, is beneficial for you. The scheme is that compounding will be done after 6 months, not annually but after 6 months, meaning the amount will be calculated after 6 months, and after for the next 6 months interest will be calculated for the amount that you get after 6 months, not after 1 year, right? So this is more beneficial for the customers who are depositing the money to the bank, right? And we say compounded half yearly. Sometimes this compounding is also done quarterly, monthly, and so on, right? So as it says, the interest is usually calculated annually, but there can be other time periods. Compound interest can be charged half yearly, yearly, quarterly, monthly, or daily, right? So for example, find the compound interest when $3,000 is invested for 18 months at an APR of 8.5% if the interest is calculated every 6 months, right? So for every 6 months, what we do is we'll use the same formula but with slight modification. The formula will become compound amount I am finding out. This is P. This is 1 plus. Now as you can see, rate of interest, which is here 8.5%, this is for whole year. But as the scheme says that the compounding will be done after 6 months, so what we do is we take the rate of interest for first 6 months as just the half of the total rate of interest. So for example, if the rate of interest is 10% per year, so for half yearly compounding, what I will do is I will take the value of R as half of 10, which is 5%. And for the next 6 months, rate will be again 5%. So yearly rate of interest becomes 10%, but compounding is done twice. Compounding becomes twice, meaning we will use the formula twice, or multiplier value will become twice. Are you getting this? Right? If the number of years, let us say, are 2, so in 2 years there will be, let us say if our number of years are 2, so these 2 years will be divided into 6 half yearly periods. Period number 1, period number 2, period number 3, and period number 4. This is for 6 months, this is for 6 months, this is for 6 months, and this is for 6 months. So for this 6 month, rate of interest will be half of, why I'm doing half, because as you can ask that since the whole 2 years are divided into 4, so rate should become 4. No, rate is given as per year always, right? So if the rate for per year is R, so rate will become half always, right? If it is compounded half yearly, right? So for first 6 months, rate becomes half. For this month, rate is again half. So this is your total number compounding becomes 2 in a year. So again for the second year, this is the third compounding and this is the fourth compounding, right? So whatever you will write in the bracket 1 plus or whatever is the multiplier, this becomes the number of times that compounding is done throughout the time period. So if number of years are 2 and it is compounded half yearly, so in place of this t, in place of this 2, you will write 4 because compounding has become double. I hope I am clear for this. And rate becomes half. And this is the change in the basic formula. So the formula becomes 1 plus, instead of r, it becomes r by 2, right? Into 100. Why into 100? Because it is just like rate is 10%, so r by 100, and it has just become half, so that's why I have written r by 2. And number of years becomes twice, right? So here it is saying for 18 months, and it is compounding half yearly. So these 18 months will be compounded 3 times, for first 6 months, for second 6 months, and for third 6 months. So total number of compounding becomes 3. So I will write the exponent as 3. And what you mean by compounding is you are finding out the percentage on the amount 3 times in the 18 months, considering rate as half of 8.5. Okay, that's why it is 3. So in crude words, you can say that you are applying this formula 3 times for 18 months. Okay, I think I am explaining more than required. So compound amount is 3000, rate is 8.5, so it is 8.5 over 200 raised to power 3. This is your compounded amount. Okay, let us find out this. So we have here 1 plus 8.5 divided by 200, it is raised to power 3, right? And then it is multiplied by 3000, and as you can see here, amount after this much of compounding is 3398.98 dollars, or you can just write 3399. Okay, and if you compare all these 3 types of questions, one was simple interest, second was compound interest if the compounding is done annually, and this is compounding half yearly. If you compare the amount after, let us say, 18 months, the maximum amount you will get is for this one, because in the first 6 months amount has increased a little bit. Okay, because you have calculated the interest and added in the very first 6 months. You have not waited for the next 6 months. I hope I am clear. So this is all as far as interest is concerned. 2 types, simple interest and compound interest. And I hope you enjoyed this video. See you soon. Thank you.